Okay. Uh, in the first lesson, we went ahead and looked at how to come up with a characteristic equation. Okay, so now we want to see is uh, want to see uh, if it's damped or critically damped, underdamped, or overdamped. So how do you do that? Okay. Well, I'm going to use some terminologies or some that are perhaps you haven't covered yet, but I think these are a little bit easier, or at least for me, it's easier to understand. Uh, okay, this is the form the equation should be. Okay, meaning that when you come up with a characteristic equation, the middle term is omega naught over q. Now q is called the quality factor. That tells you whether it's damped, underdamped, critically damped. And then this term here, that's your natural resonant frequency. Okay, so if I write the equation that you derived up on top, 2 plus s r times c plus 1 LC. Okay, so we have that. So once you have your equation, let's see if I can add. See now how do we insert a new page? Still trying to figure out how to use this. Okay, I think there's a way of adding more. Insert okay, well, maybe I can do that. Okay. Anyway, uh, okay, just keep in mind that this term is W over Q, and this term is omega naught. Okay, so let me see if I can copy this. Copy, copy, and paste. Okay, hey, we did it. Okay, so we have that. Okay, so once we have that, you have your characteristic equation. You know that this middle term is omega naught. So what you do is you solve for q. Okay, so when you say omega naught q is equal to 1 over rc. Okay, and then you know that this term is omega naught squared is equal to 1 over LC. Okay, and if you solve for omega naught, you know that omega naught is equal to 1 square root of L times C. Okay, and here, and go back to the first equation, we're going to have Q divided by omega naught 1 divided by RC. Okay. Okay. So this is the first equation we're going to use. here should have Q 1 divided by, go to LC divided by 1 RTC. Simplify it. Okay, so now we have this equation. Okay, it says Q equals RC square root of L times C. Okay, this equation is great because it tells you there's going to have three conditions. If you have a Q, you plug in the numbers, and if you have a Q of half, okay, if it's equal, then it's called critical damping. Okay, if your Q is less than, let's see if I get this right, less than half. Okay, if it's less, it's overdamped. Overdamped. And if Q is greater than half, it's underdamped. Okay. I like to use these equations because I can derive them instead of using the finding the roots and finding the alpha and all that stuff. To me, this is much easier. Uh, I'll do an example to show that